Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 64. I gotta get a better haircut because I keep on putting my hair. Number of valid move combinations on chessboard. Yeah, hit the like button, hit the subscribe button, join me on Discord. Let's see, more people have solved it. Join me on Discord where a lot of, now there are a lot more even smarter people than me and they're just chatting about the contest. So come hang out. So this one, this one is just a lot of. I think the hardest part is just the analysis. You look at the times, and to be honest, I finished seventh, but I still took 27 minutes, which I don't think this is a 27-minute problem, and some people showed it right well, because some people got it very quickly. But I think it's just an analysis problem and a weird problem in a way. I think this is one of those problems where you really have to think about the constraints. And also, I would add one more thing that I did not do is that where are the constraints at? Yeah, that they hit something really important behind the constraint, which is that there will be at most one queen on the chessboard. So this one makes the complexity a lot easier. So definitely think about that one. But basically, this made it a lot simpler, right? To do brute force. Yeah. And that's basically the idea, is to brute force simulate everything, and that's my solution. I don't really have anything good for you. N is 4, and I do 1 queen. Once I notice the 1 queen, and I can show some calculations that I did. What I noticed is that a queen can go, roughly speaking. I mean, it's actually less than this, but 32 directions. 8 in up, in 8 in vertical, 8 in horizontal, and then 8 in diagonal and 8 in diagonal, roughly, right? Or at least like that's the worst case-ish. So that's 32 times, and then the other one with rook or bishop is the same thing, which is 8 on each direction, so 16 times 16 times 16. So I plug that into a calculator, and I go, okay, 130,000-ish. And then I times that by, say, times it by 8. 8 for each of the number of spaces that each can take. Meaning you go in one direction, you go. Oh wait, no, that's not true. Well, okay. I mean, the way that I implement this like this because I have to do the simulation, so that's why I did it times this, and then times like 4 because I have to go through some loops of 4. This isn't scientific, right? I'm just. But these are the things that I kind of did during the contest to be like, okay, brute force should be fast enough, because my numbers here are also actually a little pessimistic, right? Meaning that the actual number is going to be smaller, but I'm just going to see whether this is feasible for brute force. And once I kind of realized the queen thing, I was like, okay, this is only like roughly 4 million, maybe that'll be fast enough. So yeah. So let's go over the code, because and actually my code is okay, it's not that long, but it's not that short either. But this is just setting up the directions for queen, bishop, and the rook. This is what it looks like, and then basically I just set up each of the positions for their. Maybe I could have written this a little bit differently actually, now that I think about it, but that's fine. This is basically mapping each piece to the direction that it can possibly go, and then I just do the brute force. Basically, I have 2 things that I'm brute forcing on. One is the direction of each of the piece, and then the other one is the space that is the piece, and then I just do a brute force. This is the simulation part, which I'll skip for a second. So I'm going to start line 52, and what I do here is basically I go, okay, so if I go nowhere with this piece, let's brute force that. This is really what it sounds like. It just doesn't go anywhere, right? Meaning that it didn't move. And then here, if it moves, then it takes one of the direction, and then it just goes, okay, what happens if we move it once? What happens if we move it twice? What happens when we move it 3 times, and so forth? And then we do a recursion on that, and then all the way through until we did this on brute force on every n, and then on the nth one we just do a simulation. We see if it's a valid board by just having a valid flag, but we start. Yeah, these are the the current location of each piece. And then for each time period, I check to see, I keep going until everything has moved to a spot. And of course, we check for collusion during every time step. I did it with a set here, and you can see. So yeah. So everything is very brute force, and if it's valid, then I increment. But yeah, as you can see, this is very brute force, right? Like I literally increment, like I move everything one at a time, and then to see if there's a collusion. You can actually, now that I think about it, I probably did this in a funky way. I think you can actually solve the system of equations to kind of see if it's possible. Like you can solve where they collide, right? But it's okay. That makes it way harder, but I don't know. Maybe I don't know. It's good enough for me. Good enough for the contest. But yeah, that's all I have. The complexity is really high. It's exponential essentially because it is just brute force. It's just like it's something like 8 to the n times 8 for each of the directions times 8. 8 to the n times n. Oh no, 8 to the n times 8 times n, something like that, which is, I guess, roughly speaking, O of n times 8 to the n. But yeah, that's all I have for this one. I don't think that this is too interesting for me. Did I make it? Oh, I didn't make it big. Okay, well, this is a little bit bigger. But then now this is a little bit smaller, so you can see everything in. Okay, maybe this is too small to see. I don't know. But okay. Let me just say, here's the first half. This is the parsing code. This is my simulation part. And maybe I could put this in a helper. This is the recursion part, and this is just to kick it off. That's all I have for this one. You could watch me solve it live in the contest next. Okay. Anyone finish it? People are way fast. How many pieces are there? There are most 2 pieces. Oh, n pieces. What's n? N is only 4. Oh, the blocking is the interesting part as well. Wait, did they move in order? Oh, they move 1 square at a time. Wait, what? I'm just doing 64 to the 4th possibility. That's not. That, I think brute force is the answer, right? I don't know that there's anything hard about this one per se. The invalid move is funky, but that's it. There are only 4 n. This is a typing contest, I guess. I usually write this in a systematic way, but now I'm a little bit confused. I should run it this way actually. It's too late. Okay. Forgetting this part a lot. Okay. Say what? Oh, they're not already at it. Okay. I think this part I didn't. quite correctly. No one finished it yet. Hmm. Hmm. This is too slow actually now. To about a million possibilities. Oh. Oh, huh. Okay, so that actually makes things a lot easier. I miss. Okay. I mean, I still have to worry about it, but the math is slightly easier. Okay. Okay. that's it. Doesn't feel right. This is 24. Why is this 24? I'm being really slow, to be honest, just to make sure, but okay. Why do I go once? Oh, this is from 1 to 8. That's actually a big one. I actually remember. Yeah, okay. Oh, okay, so this makes more sense. I was actually thinking about wondering why that is. But worst case is maybe 81,000. Okay. Okay. This is actually really wrong. Stop copying and pasting. This is wrong with it. Oh, I didn't comment. One second for this one. Maybe too slow, to be honest. I don't know how many inputs there might be, but this seems to be correct. Might have to make some optimization. I've got it. How confident am I? Yeah. We are doing some duplicate work. That's the issue. What is this by itself? 1 second by itself is pretty bad. Like, I think there'll be 2 seconds even. That's terrible. How can I optimize this? I thought brute force would be fast enough, but I guess the way that I'm doing is even more brute than usual. Especially this thing is 4x. So I think I have the answer, but it's too slow, and it's not even that slow. It's a little bit slow though. The thing is, I need to do this where I simulate the directions first or something, because they can only intersect at one place. But that doesn't, I don't even know if that's that much faster, to be honest. So yeah, so that check is very slow. This is much faster. Then Is it enough for me to YOLO? Let's give it a YOLO. May still be too slow, to be honest. It is fast enough. Okay. I guess I didn't think that I needed to do that move to be, or I didn't think that would make that much of a difference to. Yeah, thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about this problem, my explanation, whatever you like. On Discord, a lot of contest people now, our Leetcode contest people are there. So definitely share in the moment and you know, just chat about nerdy things. Anyway, yes. Stay good, stay healthy, to good mental health. Have a great weekend. I guess if you're watching it in the future, then maybe just have a great day or rest of the week or whatever it is. I'll see you later. Bye-bye.